to continue talking about slope-intercept form. What we are going to do today is just add on one extra step in the beginning of our problems. Remember, slope-intercept form is when an equation of a line looks like y equals mx plus b. Okay, so in slope-intercept form, m represents our slope, b represents our y-intercept. The other thing that we can see in slope-intercept form is that it will always look like, well, sometimes it looks like f of x, right? But it will always pretty much look like y equals, by itself, on one side of the equation. What we're going to see today is equations that don't say y equals mx plus b. We have to get them in that correct form in order to graph them. So, take a look at example 1. Again, our goal here is to get this equation into the form y equals mx plus b. I tried to train you on this. Remember when we talked about literal equations? Literal equations where we had multiple variables, we were solving for one of those variables. So we are going to keep y by itself on one side of the equal sign. We're going to move that x to the other side. Anytime we move something with a variable attached to it, we are only ever using addition or subtraction. Is that clear? Did everybody hear me when I just said that? When we move something with a variable attached to it, we only ever use addition or subtraction. So to move this 3/2 x, we're going to subtract 3/2 x from both sides. That leaves me with y equals negative 3/2 x minus 5. Shocker. From here, I take my slope, which is negative 3/2, and I take my y-intercept. Remember, we're trying to write these as points, 0, negative 5. This is always 0. We remember how to do this part, right? So now we take our y-intercept. I look at my y-axis. I plot that point first here at negative 5. Ooh, hello. And then I use my slope, which is negative 3/2. I'm thinking rise over run. So if I'm rising negative 3, I go down 3. Run 2 means I move to the right 2. If I wanted to go backwards, the other direction of my graph, we flip the signs. So a negative 3 over a positive 2 could also look like a positive 3 over a negative 2, where I go up 3, oh my goodness, up 3, backwards 2, up 3, backwards 2, all the way to the end of my graph. We use our ruler, we draw a nice straight line. Any questions on that? Let me see if I can get that all in there. No? No questions? All right, next example. Same deal. I know I'm trying to get y by itself. Here's y. Right there. I'm using reverse order of operations, so I should add and subtract that x to the other side first. Every time I move that x to the other side first. Minus 2x. Then what? Cody.
Divide by 3.
When I divide by 3, on the other side, I need to make sure that I'm dividing the negative 2x by 3, and I'm dividing the 12 by 3. So my final answer here should be y equals negative 2/3 x plus 4. You see how I've divided both of those pieces by 3. What's my slope here? My slope is, Jade? And what's my y-intercept? So I take those numbers and I plot them. Y-intercept goes in first at 4. I use my slope down 2 over 3. And I can flip my signs to go up 2, backwards 3. Again, remembering we can pay attention to what the sign of our slope is. This slope is negative, so I know that my graph should be going downwards. Ooh, I didn't like that. Questions? Let's do one more like this. Take a look at 3. What do I do first here? First step is what? First step is Autumn. I'm trying to keep that y where it is and move everything else away. So I add 6 on both sides, 6x on both sides. Now I have 6x plus 18 equals 3y. So what do I do now? Go ahead. Yeah. So this is 2x plus 6 equals y. Am I going to freak out because the y is on the other side than it's supposed to be normally? No, I'm not going to freak out. That's the same thing as if I wrote it like, oh, hello, y equals 2x plus 6. Same deal. What's the slope? What's the y-intercept? 0, 6. I plot my point at 6. I use my slope of 2. Can I write 2 as a fraction? What's 2 as a fraction? So that means I'm going up 2 over 1. Up 2 over 1. If I wanted to go backwards, flip both of those signs. Negative 2 over negative 1. Down 2, backwards 1. Hello? What's going on? Look at all those points. Draw your line, connect them up. Are we all okay on this? Fantastic. Let's move on. Flip your page over. Okay. Do you remember these acronyms I told you about? Yes? No? Maybe? We're going to use them some more today. We're going to talk about those special cases and what they look like when we write their equations or we graph them. So, HOI. Can somebody remind me what all the letters in HOI stand for, James? Horizontal. What is 0? Of what? It's the value of the slope. So the slope is 0 of my horizontal line. And then I kind of told you about this y, but not really. So let me tell you about this y again. The y in HOI tells me that the equation of a horizontal line will always look like y equals some number. So like y equals 11 would be a horizontal line through 11. Okay? That's HOI. Put it in your head. HOI. It doesn't make any sense. Keep it in there. What about VUX? V stands for vertical. Our slope is undefined. And then the x, guess what? That means that my equation for a vertical line will look like x equals some number. X equals 7 would be the equation of a vertical line. Okay? These are the two things I'm focusing on right now, is that I know for a vertical line, I'm looking at x equals. For a horizontal line, I'm looking at y equals. Okay? So take a look at example 5. My equation is y equals 3. Is that going to be a horizontal or a vertical line? Horizontal. It's y equals hoi. Y equals horizontal. So I look at my y-axis. Okay, here's my y-axis. I'm going to look for where 3 is on my y-axis. And I'm going to draw a horizontal line through 3. Yeah, what's the slope? What's the y-intercept? That's it. Look at example 6. Is that going to be a horizontal or a vertical line? Vertical, because it says x equals. X equals is vux. So I look at my x-axis, and I'm going to look for where -2 is. And I'm going to draw a vertical line through that point. What's the slope? What is the slope of this line? Ooh, hello. Does it have a y-intercept? If this is the y-axis, does it ever cross that y-axis? So sometimes, when it is a vertical line, our y-intercept is none. Two more, and then I have something else. Vertical or horizontal? So I look at my x-axis, I look for where 6 is, and I'm going to draw a vertical line through that point. Slope? And y-intercept? Y equals -8, horizontal or vertical? I look at my y-axis, and I'm going to figure out where -8 is. That's a lot of counting for me. There it is. I'm going to draw my horizontal line through that point. What's my slope? What's my y-intercept? Good? Okay, 2 more. I have a horizontal line here. What equation do I write for this line? Exactly. I know it's y equals 1 because a horizontal line uses hoi, and I know it's at 1 because it passes through 1. What about for this one? Perfect. X equals because it's a vertical line, -3 because it passes through -3.